continue with section 6.6, operations with algebraic vectors in R2. This is just the continuation of previous section 6.5. We already talked about the I vectors and j vectors as our coordinate vectors, right? And the last time we talked about in 2 dimensions, I is just 1, 0, and j is 0, 1. And we also talked about the magnitude of a vector, it's a norm v, right? And then for b, additional vectors is just summation of the coordinates, summation of the parameters coordinate wise, right? So for the two axes, we add them up together, and for the two y parameters by and ay, we also add them up together. And then it's the same with subtract, right? We do it coordinate wise. I think this is fine. Also multiplying by a scalar, I think is also fine. Just scalar multiply with respect to each coordinate parameters, right? And also vector equations. Let's see. I think okay, we can illustrate this using a example 6. All right, so given a and b here and solve for x, the following equations, right? Yeah, so I think it's nothing but plug this in the vectors that we know here, a and b. I think it's nothing but the usual equations that we know, but only we set up the equation coordinate wise, right? So for example, 2a, we write out 2a is 2 times negative 2, 1, right? And then we minus 3x. X vector will just use, I think, so this is x with the vector notation with the arrow, right? And so I'm just gonna write 3xy. All right, so this is our x vector, and we have b vector. And so a and b, we all know, we are just gonna plug this in. All right, already plugging the a here, and then plugging the b here is 1 minus 3. So we establish two equations for the x coordinates. So first for the x coordinates, I think we can just continue writing out this equation, right? So this is like negative 4, and then minus 3x, 3y here. And then this is y negative 3. And then I think you will be able to solve this, right? Just for the x coordinates, we're gonna establish negative 4 minus 3x is equal to 1, and then for the y coordinate, it's gonna be 1 plus 3y is equal to negative 3, all right? So, and then we solve for x and y. I think you're able to do this, and the x vector will be yeah, just the x and y that you solve for, right? All right, so write this in coordinate in write the vector in components form. Well, this is just, as we say, like a is just negative 3 and 4, right? And find the magnitude, and we just use this equation, square root of the x squared plus y squared we talked about. And then yeah, this is again like summing them up coordinate wise, and we can transform this a as coordinate notation as 3 and negative 5, right? So yeah, it's nothing but coordinate wise operation. And then example 3, find the difference between vectors. Yeah, so to find the difference, just subtraction, right? Since we know the sum, we will be able to do the subtraction and then multiply the given vector by the given scalar. Yeah, I'm sure you're able to do this. Yeah, I think this is like what we did. So okay, this one, find the parameters of the triangle. All right, so this might be, I think this is still not bad. So I'm just gonna do one side, all right? So parameter is the summation of the lengths of 3 sides, but so for example, AB, what's the length of AB, right? So first we're gonna write out AB. Is pointed out to B, right? So we're, if it's pointed out to B from A to B, we're going to subtract the coordinates of B by A, and this is going to be 2 and 2, right? And then the length, the norm of AB is going to be the square root of the x coordinate of AB, so x squared plus y squared. So this is going to be 2 squared plus 2 squared, so square root of 8, which is 2 square root of 2, all right? And then, okay, all right, unit vector parallel to vector, and this we also talk about it. The unit vector, we use a formula like A divided by the length of A, right? So this is gonna be 3, 4, and then square root. The norm always we use the square root of x squared plus y squared, all right? And then, what is this? So we have 3 points. Find C such that the polygon is a parallelogram. So if we have A, B, C, D here, usually when we write out the parallelogram, we are writing out the symbols, the points, in a way that yeah, like like in orders, okay? So AB, so such that AB is a side, and then BC is a side, and CD is a side, all right? So, and then if you write the vertices of the polygon ABCD in order, we're going to have that AB is parallel to CD, right? AB is going to be parallel for CD. So first we need to write out the AB, write out the form of AB, and then we're going to write out the form, the notation for CD, right? AB will be the B coordinate minus the A coordinates. So minus 1, minus 2, and then minus negative 2, 3, all right? And then CD vector would be the D coordinates, and then minus the x coordinate C, and then x coordinate and the y coordinate of C, right? So this will be like 4 minus xc, 2 minus yc. All right, so, and then here, if I calculate it, AB would be 1 and negative 5. All right. Yeah, so, and then these two, so we know that AB parallel to CD, so their x coordinate will be proportional to each other. So 1 over 4 minus xc is equal to minus 5 divided by 2 minus yc. So this is first relation. And then the second relation is that since it's a parallelogram, they are parallel, and then the lengths of AB and CD, they are equal, right? So yeah, so we're just gonna calculate the lengths. So we have two variables, x and y, so we need two equations to solve it, right? And the length of AB is going to be 1 squared plus 5 squared. And then the length of CD is going to be 4 minus x squared plus 2 minus y squared. Okay, so we have two equations to solve two variables, right? Yeah, so for the first variable, we're just going to write out. So xc is equal to a function of y, and then we plug this in back, right? So the first thing we're going to have the 4 minus x c is equal to negative 2 or 5, and then plus 1/5 yc, right? And then so if we move xc to here, xc is equal to 4 plus 2 over 5, and then minus 1 over 5 yc. All right, so in this way we represent xc using the yc, and then we're going to plug in this x into the second equation to solve for y, right? So plug in the x star equation into the number two equation, right? All right, so and then find the angle. All right, so find the angle between the two vectors. Let's see. So of course we're going to write out the PQ and the PR, right? The PQ and PR, this is Q minus P, so it's going to be Q minus P, negative 2, 3, and PR, this vector. Let me just write it out. Going to R minus P is going to negative 5 and negative 4. All right, so let's say this is from P to Q, so I'm just gonna P to R. I'm just gonna assume this is P because P goes to Q, right? So the arrow is goes to Q, and then P goes to R. This arrow point to R, so it's going to be something like this, right? So the angle between these two, if you know the inner product, I think, I'm not sure if you guys have learned the inner product, but I'm just gonna tell you, okay? So inner product of two vectors, because it's going to be inner product of two vectors is going to be really useful. So inner product is a dot. Inner product of PQ and PR is going to be like coordinate wise multiplication, right? So it's going to be x1 times x2 plus y1 y2, and then we're going to label this. The first PQ vector, I'm just gonna label this as x1 y1, and in the same way I'm going to write just label this, just give it a name, right? And this is x2 y2, and then the inner product is just coordinate wise and multiply their parameters together, their scalars together. So x1 multiply with x2 and plus y1 multiply with y2. So this is the first equation formula of inner product. And then the second formula for inner product is PQ, inner product with PR, is the length of PQ, the length of the first vector, multiplied with the length of the second vector, and then we multiply the cosine theta. It is exactly the theta angle between them, right? The cosine theta. So here we got the theta. So using these two equations is easier, it's very handy to compute theta, right? So these two are both two formulas for inner product. So let me just write it out. Our two formulas for inner product. Okay, two formulas for inner product, and we're using these two formula 1, 2 equations to solve together our cosine theta, right? Because for the first one, it's easy to just plug in the coordinates of these 2 points and we can already get our first equation, right? So cosine theta is just equal to x1 times x2 plus y1, y2. So this formula is good. It's handy for us. We're happy about it because we know the coordinates, so we know the vectors. We know how to represent the vectors. We know the x1, x2, y1, y2, right? So this value we can compute it, which is handy. And then the length of these two vectors is also handy, right? Because again, we are given the coordinates of the points, and so we know how to represent the vectors using the points, right? So whenever you get a set of questions, you always do this, right? You always using what you know, the information of the points, and you know the vectors. All right, write out the vectors, and then you can, using that formula, you can write out the norm of the vector, right? So this is PQ, and this is PR, this vector, right? So, and then we get the cosine theta, and PQ and PR is just the square root of the coordinate, right? So PQ will be the square root of -2 squared plus 3 squared, right? And PR, norm of PR will be the square root of -5 squared and plus -4 squared, right? And then this, and then we multiply it. So this dot is the usual multiplication, right? And then, but the inner product we use, inner product is also called the dot product, and then these two are both two formulas, two definitions of inner product of two vectors. All right, so this is the section 6.6. I guess is not that hard for you guys, and then we can keep going with the next. So let's see. So we're going to, oh, what happened? We're going to either, okay. All right. So we're going to section, okay. Wait. Okay. What's going on here?